Hello, welcome ladies and gentlemen to your video lesson for 7.3 today. Today we're going to talk about graphing linear inequalities in two variables. Two variables just mean x and y. In their previous experience, we have graphed only with one variable where we said like x or y is less than or greater than or equal to or whatever the case may be. And we graphed all that stuff in a number line, what you see below. But today we're going to incorporate what we know about slope-intercept form and graphing that. And, well, graphing a line in general, not necessarily just slope-intercept form, but graphing lines and graphing inequalities, and we're going to merge that stuff. And in the end, we're going to graph a linear inequality on a coordinate plane, and that's what we're doing today. All right. The good news is that you already know about 90% of what you need to know in order to do this. So ask yourself the question: do you know how to graph a line? And if your answer is yes, then like I'm saying, you know 90% of what you need to know for today. There's only a couple things you need to add to your knowledge in order to graph a linear inequality. So let's dive in and get some neurons firing here. All right, so the warm-up today, what we're doing is we're just graphing these linear inequalities to start. Sorry, linear equations. They're not inequalities yet, but they will be. Remember, the number all by itself is our y-intercept. So I'm going to start with that. My y-intercept is 5, so 1, 2, 3, 4, 5. There's my y-intercept. And this is my slope of 1/3. So that means I will go up 1 and to the right 3. So I will do that. So up 1, right 1, 2, 3. Up 1, right 3. Up 1, right 3. And again, using it exactly backwards. So down 1, left 3 will get me the other side of the line. Down 1, left 3. And there's my line. And I will graph it as straight as I can. That's actually pretty darn good. I'll take that. Okay, so there's that one graph. I'll pick a different color for the next one. I'm going to make it a little bit thinner. All right, so this one here, my y-intercept is -6. So I will graph that. 1, 2, 3, 4, 5, 6. And my slope is +4. Now I want to turn that into a fraction, so I'll put it over 1. So this means that I will go up 4 and then to the right 1. So up 1, 2, 3, 4, right 1, 1, 2, 3, 4, right 1, 1, 2, 3, 4. There we go. 1, 2, 3, 4. There we go. Gotta go a long way that way. And then again, exactly backwards to go the other side of the line. Down 1, 2, 3, 4, left 1. And so there is that line there. Okay, so kind of mark that a little bit, what we got. But that should be a review. That should be something we're really good at. If this is something you struggle with, you certainly need to review some of your old notes, sign up for a contact time, do some of your own research. But this needs to be pretty rock solid right now, your ability to graph a line, okay? So make sure that you take care of what you need to take care of in order to understand that. Okay, now, class from the past, graphing inequalities on a number line. This says x is less than -5. So -5 is right here. I will put an open circle on that, and I'm going to summarize that stuff in a second, because that means -5 is not part of the solution, right? It has to be less than -5. So less than would be an arrow going to the left. Okay, this is g is greater than or equal to 3.5. So where's 3.5? It's right here. The equal to part means that I will put a solid circle on this. And then greater than means my solutions are all bigger than 3.5, and that exists to the right. This way, with the mirroring, okay? Cool, and this is something we should be fairly good at. And we're gonna practice a little bit more on the next page. So without diving too much into this, I'm gonna skip to the next slide, and we're gonna talk about reviewing a little bit of inequality stuff. Each of these, number line doesn't have any numbers on it for you. So whenever you're doing it on your own, all you really have to do is put 3 numbers on there. The one that you're comparing x to, and then 1 on either side. Okay, so there's that. And now this says x is greater than 5, right? So because it's not equal to, I have an open circle, and then my arrow goes to the right because it's greater than. Things that are greater than 5 are to the right in the number line. Same thing here, we're comparing x to -3. So I'll have -2 here, -4 there. X is less than, again, open circle, because it's not equal to, it's just the less than part. And so my arrow will then go to the left. And the last one here, 1's here, we'll have 2 there, and 0 can go here. This says x is greater than or equal to, so equal to part means my circle will be filled in, meaning that 1 is part of the solution because 1 can be equal to 1 and it works. And the things that are greater than 1 are to the right. So that's how we graph on that. So I'm going to summarize a couple things for us. That's not what I wanted. This is what I wanted. Kind of summarizing what it meant to be an open and closed circle. So remember, if we have greater than, the symbol that's greater than and the symbol that's less to, that means that we have an open circle. It's not, those numbers are not included. And greater than or equal to or less than or equal to means we have a closed circle, and that means those numbers on that circle are included in the inequality solution. All right, so a couple more things here. We're going to start connecting the coordinate plane, linear stuff to what we know about inequalities, all right? In this example, we're going to compare graphing on a number line, x is less than or equal to 4, and then taking that same exact inequality and what in the world is it going to look like on a coordinate plane, all right? So x is less than or equal to 4. Where's 4 at? So I'll put 2 here, 4 there. This would be -2. This would be -4. I'm just counting by 2's. So we already know that this is going to be a closed circle based on what we remember and what we summarized on the last page. And this says less than 4. So how do we indicate where the solutions are, right? On a coordinate plane, we indicate that with an arrow. I'm sorry, not on a coordinate plane. On a number line, we indicate that with an arrow. The question becomes, how do we do that in a coordinate plane? Before we even do that, though, we have to back up and realize, how are we going to graph x is less than 4 on a coordinate plane itself? Let's think about this for a second. This is the x axis, right? And the x-axis is just a number line. So if this is just the number line, well, 1, 2, 3, 4 is here. So we could think of this as like a solid circle on 4 because 4 is included, and then an arrow going to the left, right? Well, we can think of it that way. But in the coordinate plane, we don't just have a number line going left to right. We have stuff going up and down, right? We have a two-dimensional plane rather than a single-dimension number line. So we have to consider what the y values might be. So let's go back to something that we should remember, and that is, what does a vertical line look like? Because this is really kind of like a vertical line. So anytime you have the equation form x equals some number, that is always a vertical line through the number on the x-axis, right? That's something we should remember from graphing vertical and horizontal lines. So x equals a number. Well, this isn't x equals a number, right? This is x is less than or equal to 4. But we're going to think of it that way when we graph our initial line. And so x is less than or equal to 4. We want to think of it as a vertical line through 4. So here's my vertical line through 4. Okay, I'm going to scroll down a little bit here and get the whole thing. Now, I have to try to indicate somehow where the other solutions are, right? And on the number line, we did it with this arrow, or we shaded, right, on the number line where the solutions are going to be. The thing we got to think about is like, well, where are the solutions going to be in the first place, okay? So like, let's just take this point, for example, right? This is the point 1, 1. And in the inequality, I don't have a y value at all. So what that really means is that I don't care about it. I don't care what y is. I only focus on x, and x just has to be less than or equal to 4. Well, is 1 less than or equal to 4? Yep, it's a solution. What about the point 0, 0? Again, we don't care about y, but is 0 less than or equal to 4? Yeah. So these 2 points over here, I think we can probably start tending to believe that anything left of this line is going to be a solution, right? And that's true. So I'm going to start shading over here. So on the number line, we could shade. In the coordinate plane, we do the same thing. That shading indicates that all the answers over, all the points over here are solutions to the linear inequality, okay? Now, another thing I want to just kind of throw out initially here is that this point, we said 4, 0, right? 4, 0, was a solution. because 4 is greater than or equal to 4 because of that equal to part. And what that means is that any point up here is also like this is the point 4, 3. Well, 4 is still greater than or equal to 4. It still works. So any point on this line is also a solution, but everything to the left of it is a solution. Okay? All right. Now, what about y is greater than negative 3? Well, again, I'm going to connect this to what we know about horizontal lines. Anytime we have the equation form y equals some number, that is a horizontal line through the number on the y-axis. Okay? So this is like we're going to graph y equals 3. Okay? So y equals 3, we're negative 3, sorry. Y equals negative 3. 1, 2, 3 is right here. Okay? And it's a horizontal line through that. Okay? Now, I'm telling you right now, initially what I'm graphing is somewhat incorrect. But I'm going to go back to that in a minute. Okay? Let's go back to what we're going to do for shading. Okay, so whenever we graph a linear inequality in a coordinate plane, we're always going to shade something. So where are we going to shade? And you have to, basically, it's a decision of one side of the line or the other. So where do the solutions exist? So let's just test a point, right? 0, 0 is on that side of the line, isn't it? And that's going to be familiar later on. So this is the point 0, 0. And again, I don't care what x is because it's not in the inequality. I'm just caring about what y is. So in this case, is this 0 greater than negative 3? Of course it is, right? 0 is greater than negative 3. I can test another point and say this is the point 2, negative 2, right? Well, is negative 2 greater than negative 3? Yes, it also is, right? So that leads me to believe that all of our answers are above this line. And so for that reason, we are going to shade everything above that line. Okay? And we just tested it. And we can also test the other side and say, like, this is the point 0, negative 5. Well, negative 5 is not greater than negative 3, so it's not a solution, so it doesn't check out, right? Okay. Now, here's the other thing we got to deal with. The points on the line, okay? Now, think back to this symbol before. This translated to like an open circle, right? We said that the open circle meant that the number on that circle was not part of the solution. So like, how do we indicate that on a coordinate plane? How do I indicate that points on this line are not part of the solution? And to just kind of illustrate that even further, this point here is 0, negative 3. And I cannot say that negative 3 is greater than negative 3. It's pretty clear that it's not part of the solution. So here's how we indicate that. An open circle is the same as a dashed line. So instead of having some kind of open circle, we indicate the less than or greater than symbols with dashed lines. Okay, so it tells me every point that is on this line is not part of the solution. Okay, so let's just summarize what we discovered here about those symbols. Okay, so we said that anything that is less than or greater than, okay, those have dashed lines. Anything is less than or equal to or greater than or equal to have solid lines. And we know that already this was like open circle, right? This was closed circle before. Okay, and it all means the same thing, right? This means that that point or the line is part of the solution. This means that that point or the line is not part of the solution. Cool. So let's start putting this stuff together and kind of working backwards here. It says, write an inequality that describes a set of points in the shaded regions. Now we're given a graph, and we have to write the inequality that goes with it. Okay, so the first thing that I would look at is what kind of line is it, okay? This is a vertical line, and we already know that vertical lines have a particular equation form, x equals some number, right? But it's an inequality. We know that because it's got shading. So it's not going to be x equals, okay? So we're going to have x, we're going to have some inequality symbol, and we're going to have to compare it to some number. Well, what's that number, right? Well, this goes through 2 on the x-axis. For that reason, this is 2, right? Okay. Because it's a solid line, I know that it's going to have an equal sign underneath it. So now I just have to determine, is it going to be greater than or is it going to be less than? Well, what are we shading? Well, we're shading everything to the right of 2. And that's where x is greater than 2. So it's going to be x is greater than or equal to 2. That is the inequality that is associated with this line. Okay? And that's what you should do just about every time you have a horizontal or vertical line. Just break it down. What are we comparing x or y to? Oh, that goes in the blank. Is it solid or dashed, right? Then put that symbol underneath, or don't if it's dashed, right? And then are we shading above or below or left or right of the line? And then put your inequality symbol in accordingly based on that. Okay. So now I think we're ready to put this all together. In the end, our goal here is to be able to look at this and graph it with ease. Like I said, you already knew 90% of what you need to know in order to do this stuff. Okay. So first step in doing this is graphing just like y equals mx plus b, which means we still have the y-intercept, we still have the slope. So my y-intercept in this equation is 0, 3, right? Because of that. It's not my x-intercept. My slope to get to my next point from the y-intercept is negative 2 over 1, which means I'm going to go down 2 and then to the right 1 from that. Okay, so I'm going to graph 0, 3. So 1, 2, 3. Then from there, I'm going to go down to right 1, down to right 1. That was down 3, my bad. Down 2, right 1, down 2. Keep doing that. And again, using it exactly backwards to go the other direction. All right, now before I actually graph my line, I have to pay attention to, is it going to be solid or is it going to be dashed? Now, because I have a less than or equal to symbol, it is going to be solid, right? Because of that equal to part at the bottom there. So I'm going to go ahead and graph my solid line as straight as I can. It's got a little bit off there, but you know where the line's supposed to be. And now here's what we're going to do to determine shading, okay? Before, if it's a horizontal or a vertical line, one of the two, that's really simple to know, like, oh, I'm shading above this number, and so I'm just going to, it's going to be greater than, or I'm shading below, it's going to be less than, something like that, okay? But if it's an oblique line, which is what we call this, an oblique line, which means it has a positive or negative slope, whatever, we have to do something different, and it's actually something we did earlier. What we do is test a point. We see where it works, right? And the easiest point to test is 0, 0. Okay, 0, 0 is right here. This is going to make that really clear, right? This is the point we're testing. And what's going to happen is if it's a true statement, we're going to shade the side that has 0, 0. If it's a false statement, we're going to shade the other side because we know that 0, 0 is not part of the answer, okay? So we're basically testing to see if 0, 0 is solution to the linear inequality. I'm just going to rewrite my linear inequality. Y is less than or equal to negative 3 minus 2x, right? So what it means to test this point is to substitute 0 in for x and 0 in for y, because again, we know in the past, that's a coordinate point, right? 0 is going in for y. That's got to be less than or equal to negative 3 minus 2 times 0. Okay, now the nice thing about using 0 is that, well, 2 times 0 is just 0. What we end up with is 0 is less than, I wrote negative 3, and it is not negative 3. Hold on a second. Hopefully you were thinking to yourself, Mr. Vestbach, where'd you get that negative from? It's not negative 3. My bad. That's negative, though. All right. So again, sorry, 2 times 0 is just 0, so we're left with, is 0 less than 3? Less than or equal to 3? And the answer is, of course it is, right? 0 is, of course, less than 3. And so here's what we got. We got a true statement, right? We tested 0, 0. 0, 0 is right here. We got a true statement, which means 0, 0 is part of the solution, which means we know all the solutions are on that same side. So we're going to shade the same side. 0, 0 is here. I'm going to shade that same side best I can. That's it. So those are the 3 steps. Graph it as if it was in slope-intercept form, right? Slope, y-intercept, done. Pay attention to the sign. Is it a solid or dashed line? And then test 0, 0. If you get a true statement, shade the side that has 0, 0. If it's a false statement, shade the other side. Let's try another. Again, graph it like y equals mx plus b. So what's my y-intercept? My y-intercept is 0, 3. What's my slope? My slope is 2/3. 0, 3, 1, 2, 3 is right here. So I'll graph that point. My slope is 2/3, which means I will go up 2 to the right 3, up 2 to the right 3, up 2 right 3. And again, use it exactly backwards to go in the other direction. Down 2 right 3, down 2 right 3, down 2 right 3. Okay, and I haven't graphed the line yet because I have to know, is it solid or dashed? So looking at this symbol, I have greater than. That means it's going to be a dashed line because it does not have the equal sign under it. So I'm going to dash this line the best I can. There we go. Now again, that means that any point on that line is not part of the solution. So then, again, we're going to test 0, 0. 0, 0 is right here, 0, 0. And we're seeing if that is part of the solution. If it is, we're going to shade this side that has 0, 0. If it's false, we're going to shade the other side. So let's do it. Testing a point. Substituting in 0 for y and 0 for x right here. So 0 is greater than 2/3 times 0. Well, that 2/3 times 0 just goes away, so I'm left with just, is 0 greater than 3? And well, of course not. 0 is not greater than 3. So what do? We shade the other side. So 0, 0 is right here. We tested it. We got a false statement, which means none of the points over here are solutions, which means all the points over here are solutions. There we go. All right. So again, those are the 3 steps. Graph it like you know how, slope-intercept form, or if it's in standard form, we can find x and y intercepts. Hint, hint, we're going to do that next. Solid or dashed line, pay attention to the symbol, and then test the point, 0, 0. All right. So, oh, look what I just said. A graph that does not, or a linear inequality that is not in slope-intercept form. Now, here's what you can do. You can turn this into slope-intercept form by solving for y. If you solve this inequality for y, you will know a slope, you will know a y-intercept, and you can graph it just like we did the other 2. So I would recommend doing that if you feel good about doing that, okay? So I'm going to show you how. I already have it done. So if I take this inequality, 2x minus 3y is greater than 12, and I solve it for y, again, I have to try to get y all by itself. What's happening to y? I'm multiplying by -3, and then I'm adding 2x, so my first step is to subtract 2x from both sides, and so that's what you see me doing, subtracting 2x. 12 and -2x cannot combine, so I end up with -3y is greater than -2x plus 12, because these don't combine. Now, in order to get y all by itself, I have to divide by -3. Now, I'm going to divide everything by -3. So -3 divided by -3 just gives me y. This gives me a positive 2/3. This gives me a -4. That's what I get, right? Y, 2/3 x, -4. Now pay attention to this. I flipped the symbol. Why did I do that? Because I divided by a negative. And that's a rule that we should remember from first semester. In an inequality, anytime you multiply or divide by a negative number, you flip the sign. But now it's in slope-intercept form, right? My slope is -4. I'm sorry, my y-intercept is -4. I already have that graphed here, okay? And my slope is 2/3, so I go up 2, right 3, up 2, right 3, up 2, right 3, and I can graph my line. Now, you can also graph this using the intercepts method. This is a dashed line because I have a symbol that is greater than, which turned into less than when I solved for y. Okay. And so I have my line graph. Now, we haven't done anything with like the shading yet, but what I want to show you is that you might have thought, well, why are you doing that, Mr. Vestbach, when I can just find the x and y intercepts? Well, of course you can, and here's how you do that. Remember, for an x-intercept, we substitute 0 in for y. So negative 3 times 0 just goes away. So 2x is greater than 12. We divide both sides by 2, and x is greater than 6. So my x-intercept is 6, 0. Oh, look, 6, 0 went already through the line. Perfect. Y-intercept, 0 is going in for y. 2 times 0 is 0. That leaves me with negative 3y is greater than 12. Divide by negative 3 on both sides. I get negative 4 for my y-intercept. So there that is. It worked the same way. So using either, whatever you feel best with is what you should do. Now, which side do we shade? Okay, so 0, 0 is right here. You're going to test that point. And when I substitute 0, 0 in for my inequality, if I keep the inequality in its original form, in standard form, where x and y are both on the same side, it gets super simple. Let me just kind of show you what I mean. I'm going to substitute 0 in for this and for that. Well, 2 times 0 is 0, 3 times 0 is 0. This whole thing goes to 0, and that's essentially what I'm showing you right here. 2 times 0 is 0, negative 3 times 0 is 0. If 0 is greater than 12, is 0 greater than 12? No, it's not. So that means we get a false statement, so we shade the other side. So 0, 0 is right here. It was false, so I shade the other side of the line. So there's that. Okay. Now, would you like to know a shortcut for shading? I bet you would, because there is one. And it works when it's solved for y. Let's dig in. So to summarize some of the patterns we're noticing here, I don't really know where to put myself right now. So the first thing you're going to do is always graph the corresponding linear equation y equals mx plus b, right? So you're going to find a slope and a y-intercept, and you're going to graph that. That's if it's solved for y. If it's not, solve it for y, and you can do it. Then you're going to shade the sign of the line that makes the inequality true. You may have to test a point, but how can we shade without testing a point? That's what I would like to know. So I'm going to show you this, and then we're going to go back and see how it can be used in the previous problems. So again, this only works when it's solved for y. If it's not solved for y, can't work, okay? So when it's solved for y, here's what we got. If the symbol is less than or equal to, we shade below that line. Okay, and that should kind of connect, right? Less than, below, that word association kind of makes sense, right? If it's less than or equal to, we shade below. If it's greater than or equal to, we shade above. And again, that word association should make sense. Greater than and above, right? That's where we shade. So let's just make, like, we didn't know that before. So let's go back at our other graphs and just see if that actually works, right? So let's look at the first one we did, okay? This was y is less than or equal to 3 minus 2x. It was in slope-intercept form. Less than, oh look, we shaded below the line. Worked. Awesome. This one, y is greater than 2/3 x. Solved for y, we shaded above the line. Awesome. We got it. And then this one was not solved for y, but we did it, right? And we ended up with y is less than 2/3 x, and oh look, it was shaded below the line again. Okay, so it does work out. This makes sense, and I would highly recommend that you do it. If you solve for y, then it's pretty simple to figure out where you're shading. All right, so again, less than or equal to, shade below. Greater than or equal to, above. All right, we got our application problem, then we're going to be done. So let's get it done. So Elijah, he could spend at most $8.25 on snacks for a party. Carrots cost $2 a package, and the grapes cost 75 cents per bag. Write a linear inequality to describe the situation. So I kind of have a breakdown of this, right? So what is Elijah doing? He's spending money, okay? If you think about it, anytime you go to the store, it's never really an equation problem. You don't have to spend all the money you got in your pocket. You can always spend less, right? And so I kind of want you to think about that when we talk about this. What is Elijah doing? He's spending money, and he has money, right? So I want to focus first on how is he spending it. Well, he's spending it on carrots, and he's spending on grapes. So carrots cost $2. So let's say that that's 2 times x, so 2 times the number of carrot bags, right? So let's say x equals number of bags of carrots, or just number of carrots, let's just say, for simple purposes. Carrots, I just spelled that wrong. Ugh. carrots. And then we're adding to that spending by spending 75 cents per bag, not 75.75. Let's call that Y, but then let's say that Y is the number of grapes. I know it's bags of grapes, but I'm saving time here. Number of grapes. And how much does he have? Well, he's got $8.25, right? Now, this is not going to be, it says write a linear inequality. It's not an equation. So we have to think about what symbol goes in here, okay? So how is the spending going to compare to how much money I have? Well, I can certainly always spend less, right? And can I spend all of my money? Well, yeah. So it's 2x plus 0.75y is less than or equal to 875. Okay. So we're going to graph this, but I'm just going to graph it in Desmos, okay? One thing I will do is I think I'm just going to graph this in Desmos. I'm going to show you how. Check it out. I'm going to go to Desmos quick. If you guys haven't loved Desmos yet, you might even love it more now. It's a great way to check your answers here. So our equation was 2x plus 0.75y. And that was how he was spending money, right? So it has to be less than or equal to. I'm going to go grab my less than or equal to symbol, which is right here. And how much money did he have? Was it 825? I believe so. I'm just going to double check. Yep, 825. 8.25. And there's my graph. I'm going to zoom out. And there it is. So here's what we understand about this graph, okay? And this is why I graphed it on here, because we're going to analyze this quick. I guess I can't annotate over this, but here's what I'm going to do. Every point that is in this shaded region is a solution to the problem, okay? And so what that means, except for negative numbers, I can't buy negative carrots and negative grapes, right? And so if X represents grapes, then this is the number of grapes I can buy. So I can buy 4.125 grapes, which obviously isn't reality, and 0 carrots, or I can buy 11 carrots and no grapes. And I can buy all of these in between, but because I can spend less money than that, I can also buy like one of each or 2 of each and still spend less than that, okay? So everything in this shaded area is also a solution to that inequality, okay? So you guys now have a worksheet to work on. It's 7.3 worksheet. There is a Schoology check and an accuracy check you should do with it, but this is not coming out of the textbook, okay? So there's nothing out of the textbook for today. I hope this helped. If you have questions still, make sure you sign up for an appointment. Hope you have a great night. Peace.